All right, so today we're going to be talking about access controls, and this video is going to be a little bit different than others, and notably that's because there's not going to be a lab in this video. This isn't because there's no examples of this in Hack the Box or Try Hack Me labs that I was able to find. It's just that like the one example that I thought was really good that was really going to be worth talking about was on an active machine on Hack the Box, and because of their terms of service, I can't share that information publicly. So maybe at some other point I'll come back and add that to this video, but until then, this video is not going to have a lab, and you'll kind of understand why as we continue going through it. But without any further ado, let's just talk about what access control is. So it's just how we describe the constraints that we're placing on authorized users when that comes to accessing resources or performing certain actions. So when we bring that into the context of web applications, it's the this ability to restrict our access is kind of dependent on authentication and session management, and those two things together actually allow us to access or to implement some access control. So authentication, as we talked about before, is confirming that a user is who they claim to be, and session management is just determining which HTTP requests are coming from a particular user. And then access control is whether or not or determining if a user is allowed to perform a specific action. Oh, and these vulnerabilities are somewhat common, but because like the size of applications, their diversity of implementation, all those other fun things, they can come in a lot of different shapes and sizes. So we kind of have to categorize them into a few different main distinctions. So vertical access controls can be described by placing restrictions on users of certain types. So that would mean that let's say you've got a classroom, like a virtual classroom website kind of thing. A vertical, a certain user would be there's a student user and there's a teacher user, right? The teacher users grade papers, assign stuff, and the student users submit assignments and can view their grades. Horizontal access controls have to do with restricting actions to a singular user. So that would mean, student user A can't look at student user B's grades or couldn't submit an assignment as if they were student user B. So it's implementing changes where, horizontal is just user to user type stuff. Vertical access controls relate to like things that are kind of, administrative, but not so much. Don't only think of it as administrative because there's a lot of intermediary steps between those that could be different. There's also one that's not shown on here, but it's context-dependent access controls, and that kind of has to do with like the state of an application at a point in time that doesn't really fall in either of these categories. A really good example you could draw upon is like a shopping application. A shopping cart in like an online shop, you shouldn't be able to edit your cart after you made a purchase, right? Or, after you've already submitted an order, you shouldn't be able to edit, how much you paid or what card you paid with and stuff like that. So because of the specificity of those, they're considered like context dependent, and that's how you'd kind of look at those ones. Let's go ahead and just look at some examples of broken access control, and I've kind of color coded these because I'm just going to talk about these at a little bit of length. So unprotected functionality can be used to describe just obscuring, where your admin functionality is. So for the sake of this, let's talk about like it's just a website, like a blog, right, where the admin can add and remove users and stuff. Um, Unprotected functionality would just mean that you're obscuring, the admin page. So maybe it's just admin.php and that endpoint is, oh, you can only get redirected there from the admin's homepage. Well, if I do some directory enumeration, I'll find it. And the same goes if you know there's an admin page and you know that, it's unprotected, you might just start brute forcing directories until you eventually find it. So that's not really a good way to go. Another broken access control type example would be parameter-based access controls. So it's highlighted in yellow here, but applications sometimes determine your access when you log in and then store that information as some kind of like user controllable attribute. So that could be, a hidden field, it could be cookies, it could be request parameters or query string parameters. So let's say you register an account and you try to access an admin page and it tells you, you have like the wrong role ID, and this is the request that this is the body of the request you send when you create an account. You might think, oh, well, okay, if I can't access the admin page with the role ID that I was given at registration, maybe I'll flip this bit from 0 to 1 and see if I'm an admin all of a sudden. So that would be an example of like exploiting parameter-based access controls that are, in this case, user control. Um, Platform misconfiguration might also fall in the, would be the next one, or that's misconfiguration. But basically, let's say that there's a website that lets admins add users, but the application will only show that add user endpoint, or only allows the add user endpoint to receive a post request from certain users. So maybe if the URL, post slash add user is only allowed from an admin user, maybe you can uh, change the X original URL header to the add user, and then all of a sudden that check isn't being, made. So, or maybe, changing it from a post request to a get request would be an example of abusing a misconfiguration. This normally has to do with how the endpoint is configured to handle incoming requests. So it's very, dependent on what the endpoint is doing and how it does it, but um, little tricks like that can go a long way when you're trying to circumvent these things. Horizontal privilege escalation, again, like we talked about, is gaining access to somebody else's details. So in this URL, right, you're editing a username and you put the new name and the user ID in the parameter. Well, right, if you can guess the user ID and if that's the only access control that's being done, you could just change everybody's username by just going through every single number sequentially, which would be a pretty bad look if that's the only access control that's being done to determine whether or not someone's allowed to change a name. So that's just another example. Multi-step processes, again, websites a lot of the time have like multi-step processes for things. One good example might be if you edit your username, it might have, like a "Are you sure you want to submit these changes" button that you click, or a pop-up. The problem is, if it's not verifying all those steps, so it might check, um, like only a specified user can navigate to the profile editing page, and maybe only that user can save a new name in the field, but the application might not check that the "Are you sure?" like yes button request is verified, so you might be able to submit that last step in the process without verifying that the user is correct. Referrer-based access control is literally just talking about the referrer header of a request. Some web applications use that to verify if a request is, to limit access for a certain request. Obviously, you can control the referrer header, so if you know what variable they're looking for, you can just throw that in your request. And the same goes for location-based, right? If you know an application is only meant to be accessed from, like, I don't know, like a cookie that's your coordinates and it's only supposed to be accessed from the Midwest, you could just change your coordinates if you know what they're looking for. Or if it's only supposed to be accessed by IPs in this range, then you could just change your, location header that relates to it, your IP header. So those are just kind of like the handful of examples that we can go over. And that's basically all we've got to go over. So we'll talk about prevention, but don't rely on obfuscation by itself for access control. Obfuscating is fine so long as you assume that the attacker knows the system, in which case obfuscation alone is worth absolutely nothing. Unless resources are intended to be publicly accessible, just make sure that you're denying access by default. You don't really lose anything from doing that. And also, whenever possible, try to use application-wide mechanisms for enforcing access controls. So make sure that whatever cookies you're using, whatever access control scheme you're using, all your developers are kind of unified and know how it works and know how those calls should be made. And also, at your code level, make it mandatory if you can for developers to declare access that's allowed for different resources, and make sure that you're denying access for resources that need access by default, right? Like if it's not a public resource, deny access by default. You don't lose anything by doing that. And then also just make sure that you're thoroughly auditing and testing your controls to make sure that they work as intended and as designed. But aside from that, that's all we've got to go through today. It's a really, really short one, so I'll catch you on the flip side for the next video.